Hello, good morning. So today we are going to see practical number 2 from Data Structures and Algorithms Laboratory. So this practical number 2 is about a C++ program to implement a set, which is an abstract data type. And we are going to implement this set along with its operations using its hash table data structure. So we are going to use hash table data structure to implement the operations of set, such as inserts elements in the set, search elements in the set, delete elements from the set, union of two sets, intersection of two sets, and difference of two sets. So let us start with the coding. So here you can see initially there are header files which are necessary for a C++ program, that is hash include iostream and using namespace std. After that you can see we are creating two hash tables because we are also going to implement union, intersection, and difference of two sets. So therefore we are creating two hash tables here. So ht1 for set A and ht2 for set B. So here you can see the data types for both hash tables is integer. So they will store integer, that is numbers, in 10 buckets, starting from bucket 0 to bucket 9. Okay, so these are the index for ht1 and ht2, which are actually representing set A and set B. And here we are creating a size variable. We are declaring a size variable having size 10. So this the same size variable applicable to display or to access the elements of hash table 1 and hash table 2, because both hash tables are having the same size and that same size is 10. Here you can see init function is there. So these hash tables are of type integer, they store numbers. So initially we will enter 0 values in all the buckets to indicate that bucket is empty. Okay, so bucket is empty and initially it will hold 0 value. Okay, so this is the init function which you can see here, where we are inserting ht1 of I and ht2 of I by value 0. We are initializing both hash tables with value 0. So the buckets 0 to 9 are accessed by a for loop, and that is starting from I equal to 0 and running up to I less than size, incremented every time by 1. So I plus plus. Then we are going to display hash tables. So this is the function to display hash table, where you can see the function name is display, and initially we will display hash table 1. So we will display initially index of the hash table starting from 0 to 9, and then we will display the key values present in those index or buckets or locations of the hash table. So first for loop we will display the index, that is I, and then second for loop will display the key values present in initially hash table 1. You can see here ht1 of I. Then for hash table 2, that is initially index, and then you can see the value ht2 of I. Okay, so the same for loops are used starting from 0 up to the size -1. So this is a display function here. After that, to insert in set A, you can see we are going to insert in set A. So we are this is the function to insert in set A, and this function accepts a parameter that is a key. So you can see here this is a key. So this key will be used, or it is passed to a hash function, that is key mod size, and then we will get an index of the hash table where we will insert this key. So ht1 of index equal to key. So this is how we will insert in the hash table at the location given by key mod size. So here we will display this key inserted in set A. Similarly for set B, you can see the same function is for set B, which is also accepting a key here as a parameter. And then we will process this key by key mod size, table size, which is a hash function which uses a division method. And then we will get an index. And on that index of hash table 2, that is ht2 of index equal to key. So we will display that key is inserted in set B. Now to search in set A, to search in set A, we have this function search set A. And in this function, we are having this key as a parameter for search in set A. Now we are passing this key mod size, that is table size, to generate an index where that key might be present. And then we will, on that index of hash table 1, that is ht1 of index, we will check whether the key is present. Okay, so if ht1 of index equal to key, we will display key is found at particular location or in a bucket number. Otherwise, we will display that key is not found. So why we are doing a single comparison? Because each key is a unique key. So it will be either present on its appropriate location or it is not present in the hash table. Why? Because we are not going to insert duplicate values in the set, because set does not allow duplicate values, right? So we are not going to search keys by probing, like linear probing or quadratic probing. So either the key is present or it is not present in the hash table. So here we are searching in set B. So this is a function to search in set B. And you can see there is a key parameter which is passed to the function set integer key. Now we are searching this key. So we will do key mod table size hash function, and then we'll get an index. Now on that index, if ht2 of index is equal to key, we will display again the key is found at in particular bucket, and that bucket number is nothing but index. Otherwise, key is not found. So the similar function for searching in set B, okay, which is completely similar to searching in set A. So now we will see the delete function. So what you can see here on the screen is the delete function for deleting a key value from set A. So here you can see we are passing a key as a parameter to this function. Then we will generate the index like key mod size, okay, by processing through a hash function. And on that index, we will check whether the this key is present on hash table 1's index given by hash function. So if it is present, then we want to delete it, right? So just replace this key value by 0, because 0 in our program indicates an empty bucket having no value, right? So replace this ht1 of index by 0, and then you can see this key is found in bucket and it is deleted. So such message we are displaying here just to inform the user. Otherwise, if that key is not present on that particular index of a hash table, we will display that key is not found, and hence we cannot delete it. Now, similarly for deleting a key from set B, this is a function. So delete set B, or a key from set B, and here is a key which is a parameter passed to this function. Now this key is used to generate an index like key mod size using this formula or a hash function. Then on this index of hash table 2, that is ht2 of index, we will check whether the key is present. So if it is matching, then we will replace this key by 0, that is ht2 of index equal to 0, because we want to delete this key, right? So, and then we will display the message key found in particular bucket number, and it is deleted, right? Otherwise, we will display key is not found. So this is all about insertion, deletion, and searching. Now this is a one function which we are using in union operation, that is a duplicate function. So this duplicate function actually check a value which is passed to it in set A. Okay, so this value which is passed is from set B, and this function checks whether that value is present in set A. So if it is matching with any value of set A, it returns 1, otherwise it returns 0. So you can see here we are accessing a complete ht1 hash table 1, and then we are comparing this value with each value of set A. If it is equal or matching, then we return duplicate, or we set duplicate equal to 1. Otherwise, it will remain 0. And then we return that duplicate value. So if duplicate equal to 0, if that value is not present in set A, it is not common with set A, and if it is 1, it is duplicate, right? So in union, we are going to use this duplicate function here. So this function is about union of two sets A and B. So here you can see we have declared in variables I and j. So I will act as an index for set like set A, and j will be the index for resultant set, and that is C. Okay, so here initially we are declaring a resultant set C, which will store the union of two sets A and B. So C is the resultant set as mentioned here, and then j equal to 0. As you can see here, j equal to 0. So j is the index for C, array C or set C. And then this is a for loop starting from bucket 0 to bucket 9. It will check all the buckets, and if that bucket is having a non-zero value, so if the bucket is having non-zero value, then copy that value into the resultant set and then increment the index of resultant set, that is j. So this is how we are copying all the values of set A initially in resultant set. Now when we are copying all the values from one set and we are taking union of two sets, so while copying the values of another set, that is set B, okay, we will check whether that value of set B is initially non-zero, right? And then we will check whether it is duplicate with set A, because if it is present in both set A and set B, we have already copied it from set A, that is hash table 1. So we will not copy it again. So this is where if the duplicate function returns 0 for ht2 of I, then only we will copy that value from set B into the resultant set, that is C, and then increment its index. So this is how union is done, and that is the result is stored in set C. So then display this union of two sets, where j will act as a count of like number of values in array C, and then we will display C of I. Okay, so this is union of two sets, and then we will go for intersection. So here you can see this is the function for intersection of sets A and B. So intersection AB, right? So here we have I and J. So I will act as an index for hash table 1, and J, sorry, yeah, and J is there. So as we are doing intersection of AB, so here we have declared the resultant set, that is resultant array, and that is C. So this will store the intersection of AB. So initially this j equal to 0, which is the index of resultant set, where we are copying the values from set A and B if they are common in both sets A and B. So how we will check common values using a duplicate function. So initially we will start this for loop, then we will take one value from ht2 of I, that is second hash table, and if that value is non-zero, then we will pass that non-zero value to the duplicate function, and if the duplicate function returns 1, that means that value is also present in hash table 1, that means it is common in set A and set B, then only copy this value into the resultant set, that is C, and then increment its counter, its index by j. So this is how we get common values from set A and set B, that is hash table 1 and hash table 2, into resultant set C, and then we will display them like this. After this, we will go for difference of sets A and B. So this is a function which will display the difference of set A and B. So here we have declared I for, which will act as an index for hash table 1 set A. J will act as an index for hash table 2, that is set B, and K will be the index for resultant set, that is C, and flag is used here. So let us see what is the use of flag. Initially initialize the index of resultant set, that is K equal to 0. Now we are using this first for loop as we are going to get a set A minus B. So this outer for loop represents set A. Initially flag is 0 for the first value of set A, and then we will check first value of set A with all the values of set B. That means we will compare one value of set A with all the values of set B here in the inner for loop. So inner for loop is for set B, and ht1 of I will be compared with all the values of ht2, that is ht2 of j. And if one value of set A matches with any value of set B, we will set the flag as 1. So after this all comparisons, when we come out of the inner for loop, we will check if the flag is 0, that means the value of set A is not present in, or it is not matching with any value of set B, that is A minus B. So copy that value into the resultant set, that is C of K, and increment its index by 1, that is K plus plus. So this is how we will compare each value of set A with all the values of set B, and those values of set A which are not common with set B values will be only copied into resultant set. So that is A minus B. Now B minus A will be completely opposite. Like here you can see inner for loop is for set B and outer is for A. So here it is A minus B. Now when we do for B minus A, outer for loop will be for set B and inner for loop will be for set A, like shown here. So here you can see this function is for B minus A, right? Difference between sets B and A, that is B minus A. So here also we are having index I, j, k, I for set B, j for set A. Now this outer for loop is for set B because we will check one value of set B with all the values of set A here in the inner for loop. So ht2 of I is compared with ht1 of j, and if it is matching, then we will set the flag. At the end of this inner for loop, we will check if the flag is 0, then that means that value of set B is not common with any with set A. Then only copy that value of set B, that is hash table 2, into the resultant set. So this is how we are finding B minus A. And then display this difference B minus A, that is set C having its size in K. So this is the main function where we are actually calling all the functions like init. First init we are calling to initialize hash tables. Then we are displaying hash tables. After that we are going to insert keys in hash tables, like we are inserting 1, 3, 5, 7, 9 in set A or hash table 1, odd values between 1 to 10 in set A. Then even values between 1 to 10, that is 2, 4, 6, 8, 10 will be inserted in hash table 2, that is set B, and then we will display. Then searching, we are searching for 1 in set A, we are searching for 2 in set B. So let us initially see the display, like after initialization, this is the hash table 1 where all the bucket numbers are given 0 to 9 and keys are all 0. Now here initially hash table 2 is all 0, keys are all 0, all buckets are empty and bucket numbers are 0 to 9. Okay, so after this we are going to go for insert function, right? So we have seen that we have inserted odd values, right? So here you can see we have inserted odd values like 1, 3, 5, 7, 9 in set A and 2, 4, 6, 8, 10 in set B. So here this is a display, like hash table 1 shows 1 is inserted on location 1, 3 is on 3. By why? Because 1 mod 10 is 1, 3 mod 10 is 3, 5 mod 10 is 5, 7 mod 10 is 7, 9 mod table size is 9. Similarly, 10 mod 10 is 0, 2 mod 10 is 2, 4 mod 10 is 4, 6 mod 10 is 6, 8 mod 10 is 8. Okay, now we are searching. So see, we are searching 1 in set A. So 1 is present in set A in bucket number 1, right? So you can see 1 is present in bucket number 1. Now we are searching for 2 in set A, but in set A in hash table 1, 2 is not found, right? Now we are searching 4 in set B, so it is present in set B hash table 2 at bucket number 4, right? And we are searching for 7 in set B, so 7 is not present in hash table 2, so it is not found, right? So similarly we have here deleting keys. So this is how delete 1 from set A. So key 1 is found in set A in bucket 1 and it is deleted, right? So you can see here hash table 1 was present at location 1 and it is deleted, right? Now 2 is not present in set A, so it is not found. Now deleting 4 from set B. So 4 was present in set B at location number 4, I think. Yes. So you can see here 4 is deleted from set B, right? Now 9 is not present in set B, so it is not present, right? It is not found. Now we are inserting some keys for union intersection operations like 2 in set A, 4 inserted in set A, 4 in set B, and 9 in set B. So this is the current status of hash tables. That is in set A, that is hash table 1, we have 2, 3, 4, 5, 7, 9. And in set B, that is hash table 2, we have 2, 4, 6, 8, 9, and 10. So when we go for union, initially we copy first set, that is 2, 3, 4, 5, 7, 9. So you can see here in union 2, 3, 4, 5, 7, 9 is there. But after that, set B values are only 10, 6, and 8. Why? 10, 6, and 8. Why? Because 2, 4, and 9 is common, right? So we have taken them already once, so we will not copy them again. So this is the magic of duplicate function, right? So here we have avoided duplicate values in union, right? So this is what union of two sets A and B, right? So after that, we will go for intersection. So as the 2, 4, 9 are the common values between hash table 1 and 2, so the intersection of sets A and B is 2, 4, 9. Okay. After this, we will go for difference of sets, and that is A minus B. Okay. So you can see 3, 5, 7 is present in A, but not in B. 2, 4, 9 from set A are also present in set B, right? So what is that A minus B? C. 2 is present in A, in B also. 3 is present in A, but not in B, so 3 will come. 4 is common, 9 is common. So A minus B will be 2, 3, 2, 3, and then 5, right? 2, 3, A minus B will be, yes, 2 is common, so it is 3, 5, and then 7, right? Similarly, B minus A will be 10, 6, 8. Why 10, 6, 8? Because 10 is present in B, but not in A. 6 is present in B, but not in A. And 8 is also present in hash table 2, but not in hash table 1. So 10, 6, 8 is what? B minus A. Okay. 2 will not come, 4 will not come, 9 will not come, because they are common in both sets, right? So A minus B is 3, 5, 7, and B minus A is 10, 6, 8. So these are the operations, that is difference, intersection, union, then insert, search, delete, and display. So these are the operations on set, which is an abstract data type, and we have implemented this set along with its all operations. So this is how we have called the functions here inside main. So this is where the main starts. So initially we have initialized the hash tables like init and display. Then we have inserted the keys 1, 3, 5, 7, 9 and 2, 4, 6, 8, 10 in hash table 1 and 2 respectively. Then this is how we are passing the keys to search functions and then to the delete functions. And then we are inserting these keys again before union intersection. And then we are calling these functions union, intersection, difference, that is a minus b, and then b minus, and then finally return 0. So this is all about the practical number 2. I hope you understood this logic of the practical number 2. If you have any doubt, you can discuss it later. So thank you.